Welcome to YMT112 Algorithm and Programming 2. Today we'll be discussing chapter 15, and this is the first session. Chapter 15 is discussing recursion. So we will be addressing or solving questions related to recursion or recursive definitions or functions. So in basic sense, we have different types of recursive methods. We will try to cover some of them with different ideas. Let's go through these questions without using iterative or repetitive printing. So you shouldn't use a loop, or you shouldn't repeat typing the output statement display 10 steps to the screen. So we need to display 10 steps to the screen without any iterative or repetitive printing. That means we shouldn't use system.out.print 10 times. Neither should we use iterative approach, that means a loop. How can we do it? We can use the recursion, and in that case we have to define a recursive process. In order for us to do so, we can use two methods. One of them is calling the other, and in that case we can control the process of our method based on some base step and incremental step, okay, or recursive. Actually, in this case I shouldn't say incremental, I should say recursive step. Okay, so now what we are looking for is checking these methods and how we can write them. We need 10 steps. Let me start by the main method. The main method is a must for our display to be realized. So what I'm going to do, I will just type one statement here, method, I'll call it method A, okay, I'll pass 10. You can do it by another way. There are other ways, actually, not only this way, but I would prefer to go for such an easy or actually clear process or scenario. And then I would create this method. I'll define it, static void, and then I give a definition of method A, not methods, method A. And what I'm going to get here, I'm receiving an integer by default, so as an argument I'll just create my parameter here. I can use n. Right, so what I'm going to do, I'll just check a base step. Now 10 times, that means we can move from 10, the one passed here, we go until, or we can decrement each time and until we reach to 0. When we reach to, actually before reaching to 0, that means until 1, that means we counted backward from 10 to 1, that's 10 steps. Okay, so what I'm going to do is I will create this condition. If n is greater than 0, what should I do? Now I would like to call another method, because I said I will explain in this session, or these sessions actually for the chapter, different types of recursion. So here I'll call another method, and this is what we call indirect recursion. A method is calling another method which is already called from another method, okay? And I will pass also n, okay? And that's it for this method. I will just create another method, static void. So now I'm not going to return anything from method B, I'll just display. So method B, I'm going to receive an integer. I can call it n also. If you want, you can use any other name. We agreed before about the local parameters. We explained about them, and it's up to you with customizing them. Now we need to display 10 steps. It's up to you to customize the way display. I'll just say like this, step, and display the number of step, or where exactly we started, which value we started with, and then what I'm going to do. This is a normal display, so this is a method receiving an argument here, and we are just displaying the parameter that received or the argument is assigned to. So initially it is 10. Then what should we do to alter this process? It's recursion, so we have to call A, method A again. So I will call method A. What should I do? Since it is recursion, then we have to have some sort of change in the parameter passed, or in the argument passed in this case. What I'm going to do, I'll have pre-increment for my variable here n, and pass it back to a. So method a recursively will just do the process again with n after decrementing it. So the new n will be n minus 1, and repeat the process. Check if n is greater than 0, yes, 9. Call method b and pass n. N is 9. So now n is here 9. It will display 9. Decrement, because this is pre-decrement. So decrement n, that is 8. Call a and pass it to it. And repeat until we reach to 1. 1 would be fine, greater than 0. Until we reach to 0, then it will check the condition. It wouldn't fit, there will be no call, and that's it. It's terminated. Let's just run. Now let me just stretch this one out so that you can properly see. Step 10, 9, 8, 7, etc. So this is the recursion that we usually use indirectly. A method is calling another method which is calling the second method. So you may call a method from another method that calls another method like this. Now look, maybe you got confused a bit. The main method is calling A is calling B is calling A. Okay, so this is exactly the idea. Main method is calling A is calling B is calling A. Okay, and that's how we usually give these examples, like as a challenge, like requesting from students to create such a scenario without iterative or repetitive print. You could print system.out.print new line step, then change n, for example, 10 times. But if we ask 100, well, you can do it, but it will take time. How about if we say million? You cannot do that. So you will have to use the computation power, and you can apply a recursive process in this case, and will just work fine, like in this, similar to this, I mean. Now, is it the only way we can do it? No, this is not the only way you can create a recursion process or recursive process or recursion as a scenario. You may alter this whole view, and there will be no problem. You can use only the main method and another method. That's possible. I just wanted to show the indirect way of calling a method from another method, which is actually calling the initial method. So this is the idea, and that's it for the first question. I create another session for the second question. Until then, have a good time. Goodbye.